Hey everyone, Brian Beeler here from Storage Review, and today we're going to take a look at Supermicro SuperCloud Composer. Now, this is a whole new direction for Supermicro, going with software forward focus. I mean, we all know them from, I've got a couple of their blades sitting on the desk here from their blade chassis. We've got dozens of their 1U and 2U traditional servers that have come through the lab, but they're really taking now a software forward, solutions forward approach to their offerings. Now, SuperCloud Composer is really interesting because it starts to give you great visualizations into your data center and how to pull components from different parts of the data center, assemble them into something useful, whether it's servers or GPUs or storage and networking, on all these things, and then deliver them in a cloud-based consumption model. And this is really the next step for Supermicro in terms of management and capabilities. And there's so much here that wanted to bring in a friend of ours and an expert on this solution, Kevin Culp. Let's just start right in on it, Kevin. This is the dashboard we're looking at for SuperCloud Composer, and I love this thing because of the visuals, because of how intuitive it is. But you tell me, give us the quick pitch on Composer and what Supermicro is trying to do here.
Yeah, thanks for hosting me today, Brian, and I'm happy to be aboard here with this presentation. So right here, we're looking at the dashboard, which really gives you a day two operations view of how your data center is operationally happening. From the dashboard itself, each of the various different quadrants are broken down in technology buckets where you could basically drill down into various types of observations of the component level to the server level to the rack level. And so the dashboard really gives you a 20,000 foot view of the data center itself. And
Now, so,
again, go.
so how big does a data center need to be able to take advantage of SuperCloud Composer?
Yeah, great question, Brian. So we have been scaling out and building our architecture in support of a global data center view where we will get oversight or holistic view of 10,000 monitored hosts. We're tracking to be able to provide additional particular scalability for larger particular deployments.
So we've got the management piece. So, and we can talk about it as we get into lifecycle bits of this, because there's the traditional server management style, and now there's this as an option from Supermicro, and then the composability piece. So pick one of the two paths, and let's take a look at some of the more detail in Composer.
Okay, so let's start with just focusing on lifecycle management of day one and day two operations. So I'm going to take you back to a day one type of framework where you have your servers that come into, say, a shipping dock, you unwrap them, and the key is speed and agility of bringing those servers up very quickly to be able to run your workloads. So here you're looking at Pod View, which gives you a visualization tool of really a rack management view of how we provide visualization of servers themselves. So you have this concept of a pod where we group racks together based on common workloads, and we provide various different metadata that you can pull from each particular server to be able to drill down into the component level to basically look at each component within the server itself. So here we have a particular blade. By clicking there, we can basically see here that we have blades that are presented based on VMC IP address. And then we also have the switch oversight in regards to what's connected into the blade switches and how they interconnect through our topology diagram, which I can show a little bit later.
Yeah, by the way, the pod view is one of my favorite aspects of this whole thing, because even just in our data center with 8 racks in the main lab, walking in there and hunting for something can be difficult. Even when you have physical access to the lab, with a visual thing like this, it's so neat to be able to say, location, rack U, here's the thing.
Yeah, so basically what we have is we have this concept of universal plug and play or device discovery. So when a device actually powers up within the rack, we automatically provide metadata back to what we call the discovery agent is running under the hood of SuperCloud Composer that provides very rich metadata that we use to register within our drawer configuration. So really, it's a slot identification that we provide here within our Blade environment. So you can simply, by dragging and dropping various types of devices that have been device discovered, you can actually go through what we call our wizard to register these particular devices within the drawer configuration or the backend database itself. And by simply saving, you see that it will eventually be removed from the discovery pool and then placed into the rack itself by just hitting the submit button. And at that point in time, you will see the JBOG, in this case, accelerator pooling appliance by Giga.io that I have demonstrated here within the rack configuration.
So the note about Gig.io is interesting because it's possible, and I'm sure that your sales guys would be terrified to hear me say this, that a environment may not be only Supermicro componentry. So what you talked about Gig.io, and I know you guys have a relationship with Weka as well. What else can be supported within SuperCloud Composer, either in a limited way or visually or Lifecycle? Tell me about that.
Yeah, so if we drill down into the performance metrics system itself here, we provide oversight based on in-band management of NVIDIA's GPUs. So whether it is a converged server, such as a GPU inside our GPU servers, or it's being recognized across a network fabric through Gig.io, we provide performance metrics in how your particular GPU is performing based on workloads. So this is our performance metrics, and you can drill down to various different widgets. So it gives you kind of a Grafana-like interface where you can pull down and look at various different widgets, such as power draw, GPU temperature, and et cetera, and various different ways that you can look at based on a gauge meter or statistical sampling of min-max tables and so on and so forth. So some very interesting graphs that you can pull in that are really real time that pull in metadata from your GPUs, whether across a network fabric that we're utilizing through Gig.io or through such as a converged server GPU server itself. We also provide storage metric information of our Weka IO. So we are partnering very closely with Weka IO as well to provide you, again, oversight based on performance metrics associated with the Weka IO cluster. So you can see here by moving the various different types of cards within the dashboard provides you the ability to get an oversight of how your Weka IO cluster is basically performing. And we provide the same methodology in regards to widgets that you can basically collect based on the Weka IO cluster.
Every IT guy that has to report up the chain to some sort of management person loves the concept of things like meters and dashboards because not to disparage leadership in an organization, but they don't always understand all of the IT concepts. When you give them some pretty dials that are easy to consume, that's always useful. So
Yeah.
so look at also when we go back to pod view or go into a system view, let's look at some of the lifecycle bits there too. That was one of the things I started with. Servers forever have had a management port for out of band access to updates and BIOS and all that sort of thing. So some of that, or maybe all of that now, you've got bubbled up through Composer as well, right?
Yes, that's right. So our particular product is very structured around ODIM, which is Open Distributed Infrastructure Management. and it completes both the day one and day two lifecycle management that you would look to see from a single pane of glass, a one size fits all. And here, what you're looking at is the compute list. This is showing you registered hosts that have gone through the registration process of PodView that were visualized in the rack configuration. And it provides you, again, within the buttons here, a lifecycle management where the user can basically click or hover over and provide you management, power management, UID, tagging, erasing of systems such as simplified storage, local storage, such as a secure erase or a one zeros pattern of erasing simplified storage. And then also gives you the ability by just simply clicking here and then launching basically the BMC itself. So part of our vision is we want to try to provide the tools necessary to obviously, drill down into the BMC, but that requires an additional click. So if we can provide additional tasks or resources within SuperCloud Composer to minimize those clicks for an end user, that's a huge value add for data center operatives.
Well, and you've got ILO and iDRAC support as well for this or for some of this. Tell me about that.
Yes, absolutely. So again, based on the ODIM standard on third-party support in the Redfish capability of both HP and Dell and any third-party entity out there, such as Lenovo, Quanta, Inspur, we provide that level of ability to essentially pull in essentially the ILO itself. So by simply clicking on, again, the IP address of the ILO, you can simply go ahead and you can see here, based on this example, to go directly into the ILO itself by opening up the connection to the ILO of the HP system, the client system. And we provide the same functionality for basically Power Edge servers for iDRAC for Dell.
Yeah, I mean that's kind of nifty because I think if we think about how IT administration is going or will be or the direction of or whatever, clearly management, ease of management, flexibility of management, all of these things are becoming really important, especially for any org that's gone to the cloud in a meaningful way and now maybe is adjusting their cloud on-prem balance or managing a lot of locations, but still want to treat it cloudy. That kind of getting all of this into one system is really nice as the launch point at a minimum, right? From just a ease of management standpoint.
Yes, totally agree. Yeah, this is going to bring a big value add to Supermicro to really kind of start playing as a key player in the enterprise space. So providing this functionality and capability for third-party support is a huge win for Supermicro.
Yeah, no doubt. Okay, so we talked a little bit about administration of machines. The other thing we started on at the beginning was the other path of building infrastructure and combining parts across disparate systems. And we've got concepts like fabrics for GPU and storage delivery. So let's get into that because that's really the administration is neat as a starting point, but the deployment is really pretty sweet in this thing.
Yeah, for sure. Based on what we're doing with GigIO is really a full integration with their particular fabric switch. And every type of call that we make is standardized based on Redfish into their fabric service. So where we differ with some of our friends across the aisle is we're providing a CDI lifecycle management. So what does that mean? That really takes an end user or data center operative from device discovery, such as accelerator pooling appliances and also PCIe switches, bringing them into the fold and registering them within PodView, and then moving through the lifecycle management of deployment of these GPUs and allocation of GPUs and storage through what we call PCIe top of rack switch provisioning. And so by doing so, we're aligning that with a pre-provisioned fabric. When you look at this pre-provisioned fabric, you see specifically switches here that are showing up in the pre-provisioned fabric. And the GigaIO switch itself has the intelligence built in to basically discover these types of hosts that are through the PCIe connections they have. And how we do that is based on cable IDs. And this device discovery that we're seeing here, you see these particular devices are what we call transparent. There's no color coding associated with them. And we would take the user through loading a configuration and topology into actually deploying the operating system, putting in the bits for our exporter that's going to be presented through Prometheus so that we can get oversight into how these hosts are performing based on workloads, into what we call allocation of GPUs and basically storage. So it's the complete lifecycle management, everything from device discovery right out into essentially allocating the resources such as GPU and storage, such as NVMe flash from a JBOF, or an NVMe over Fabric workload. And then we'll continue to go up the stack and provide much more capability based on workloads associated with PyTorch and distributed TensorFlow based on software as a service. So moving up the chain is going to be very important for those high performance computing and AI data scientists to get oversight on how their GPUs are basically performing.
Right, how they're performing and the utilization is pretty big deal too. With the cost of this infrastructure with GPUs, the scarcity in some cases as well, making sure that they're operating as much as possible is pretty key too, I would guess.
Yes, absolutely.
So outside of the CDI world, what else within Composer is exciting to you? I hit on the two things that I like, but what else is exciting to you?
Yeah, so the networking piece of this really provides, again, oversight associated with zero touch deployments and zero touch provisioning of network switches. So most of the enterprise customers and various different verticals, such as telco operatives, are looking for again, one size fits all to be able to deploy switches, network switches based on top of rack switch provisioning. So you can see here we have our Arista plugin, which we have now provided to our Supermicro customers, that provides you insight on operationally how a switch is performing, such as the MAC addresses, showing you the various different port levels, itself, showing operational status of the ports. We use different color coding schemes to show you how a server is connected versus an uplink port. And then we provide you a very slick GUI that helps you run through a GUI wizard and basically plumb out VLANs to each one of those ports. So this is really getting a lot of traction with some of our Supermicro customers. Not only are we doing it for our Supermicro switches, we're also doing it for third-party support, which is, again, a huge attraction in the telco space and some of the verticals in the enterprise space.
Well, I mean, we've talked about it a couple times just through SuperCloud Composer, what you can do, but also the fact that you guys are using open standards to be able to interface with other companies. So this is very much not a Supermicro sandbox. This is very inclusive in terms of the other types of devices and vendors that you'll work with, which is important because for adoption, it can't be locked down, right? I mean, it would be kind of neat from a device management standpoint, but the tighter you lock it, the less useful it is. This open approach is pretty strong in terms of increasing the avenues for your customers to adopt Supermicro when they care to, and but also recognizing that other stuff may exist in the infrastructure.
No, absolutely. And really it's about, like you really hit on that main point of open standards and attraction to be able to be in a non-proprietary type of environment and not be locked in. And we really are trying to open up the doors in the industry to be an industry player of really providing open standards. Absolutely.
Yeah, the switching piece is a good one too. I mean, I know in things that we deploy and listening to Kevin cry about when there's ever problems, they're almost always in switching. The network is always to blame, at least by storage guys anyway. Um, okay, so what else is there that's pretty cool that you might like to show us?
Yeah, so I also want to show you also our topology view. So right now we're calculating a one hop count, how things are interconnected within your infrastructure fabric itself, infrastructure management. So we provide you with really oversight on how servers are basically performing, such as if you have a critical roll up where a server has been identified as a problem or a pain point where it's actually gone down. We provide a red type of icon to indicate so. In this case, these are green here, which indicate there's good standing associated with the server. This one is basically showing you a warning indicating that there is a problem with it. So if you want to look at what the switch has been configured based on VLAN presentations, all of this information is harvested based on link layer discovery protocol. And each one of these you can take a look at, which really provides you which VLANs have been plumbed out to which ports and how they're interconnected. So you can look at various different hop counts of intersection between switches and how they're actually interconnected. So this is going to be huge of providing visualization for day two operations when a data center operative is really looking at which particular systems have gone down or have become critical. And so we expect, data center day two operations staff would be probably looking at this or having this up most of the time within their operation center.
So, how much remediation can be done here, or is the trick visualization and then use the other tools to fix these problems? How much of it can be done within Composer?
Yeah, that's great. Great question. So, if I understand your question, is that if we had such as a critical roll up of a server itself, um, by simply providing the warning status was critical, it would basically launch you into really what we call the BMC events and activity that's occurring. You can see here where we provide information about cell and mel information that's been harvested through standard redfish. So we have these things called southbound agents that communicate with BMC and provide all that metadata up to the composer, which is a traffic cop that really controls SuperCloud Composer itself. So you can look at various different log information. And this log information can also be passed based on what we call policy-based events or what we call call home events. And you can simply go in there and through call home actually send trigger events based on policy base that you create to different servers, such as an NVMe drive reporting a critical event or a GPU overheating. All of those are available to you within our call home feature. So by default, it's disabled. You would just simply enable it. And then you can build your policies based on sending them either to an SMTP relay host or also through an SMS service that you have, such as your mobile phone, or even we're looking at other options based on Slack integration and also ServiceNow.
Yeah, well, there you go. More integrations to make this easier to consume. So I had asked you before when we started about scale, and obviously this can scale very large, but we just did that Superblade review, and you could use SuperCloud Composer even at that scale, or I mean, do you need more than one server, I guess, if you really wanted to play with this and experiment?
Yeah, so great question. So at this point in time, as we move into SuperCloud Composer and really our global data center view, we'll start looking at a distributed architecture where we'll start basically putting various different entities such as a Grafana like server in a cluster and provided an external to SuperCloud Composer. So right now, currently, the platform can run on a VM. It can run in anti-infinity. So if you wanted, to minimize the single point of failure, the VM could be presented on two hypervisors that are running in different racks across different PDUs, or it can also be configured as a bare metal server in a high availability environment where we run in active standby. As we move to a more distributed architecture, we'll start basically using a load balancer on the front end and provide an active-active configuration where there will be multiple particular composers that are federated together to provide that scalability, Brian, that
Hmm.
definitely our operatives or customers are looking for.
All right, go back to that dashboard home screen again. I just want to make sure we revisit that as a reminder for what it looks like when you're greeted with this thing. So for customers that want to try this out, I know you've got a trial. You've also got some labs that the customers can access. But what's the best way to check this out?
Yeah, so we actually would ask customers definitely to pull this up in their sandbox, really understand the value add of what SuperCloud Composer basically provides them, and we would be willing to work with them as Lighthouse accounts to learn their pain points, to improve their end user experience, and build in those rich features that really are going to help them drive their data center operation.
Okay, and from a licensing model, how does this work? Is this based on hosts in the system, or how does that come together?
Right. So if a customer chooses to deploy a trial license, we provide the ability to activate 200 monitored hosts through a 90-day trial. And if the customer decides at that point in time that they want to move forward with SuperCloud Composer, we enforce licensing at the monitored host. And we also require a advanced BCM license, which is DCMS, which provides the redfish functionality which the customer will need to purchase. That is a requirement of SuperCloud Composer, including the monitored host we enforce
Okay.
licensing.
All right. Well, this is great. I know we're going to keep diving into this more as you continue to expand. I know you've got upcoming Supercompute 21 sessions and demos, which is very cool for that audience. I think HPC will dig this in a major way. And we will put links to SuperCloud Composer in the description on the comments or the description area on YouTube, and also a link to that 90-day trial form to fill out if anyone wants to check it out. Kevin, thanks for joining in. This was a great session.
Yeah, and thank you for hosting me today. It's great to be on board here.
For more information, please visit us at www.supermicro.com, featuring 3rd gen Intel Xeon scalable processors.